Question is, you're looking at neurons. It seems like if I equate it to studying a computer and a black box approach, it's like I'm connecting oscilloscopes to different parts. I'm not studying the software aspect of it by just looking at signals. Is that an analogy? Or
no, I think it's a very pernicious one. I mean, that's one I grew up with. That's the one we all grew up with. But there is no software in the brain, right? That just doesn't exist. There are neurons, there are voltages, there are dendritic potentials, there are synapses, but there's no software. There's no universal programming entity. There's no register of things like that. You can use those terms, but I think they're much more misleading, and they will lead you to construct totally erroneous theories.
Conditioning is one kind of programming, isn't it?
Yeah, you can think of it like that.
Okay.
You can think of it like that, but there's no universal programming. There's no programming language around this. The program assumes a Turing machine, all those things, and I think those are all very misleading, and they don't really help you conceptualize the real problem of biology. That's my opinion.
First of all, is the brain a digital computer? For 50 years, we thought yes, and the answer is really no. In some sense, we run a wild goose chase for the last 50 years, thinking that the brain is a digital computer or a Turing machine. A Turing machine has inputs, outputs, and a program. But the brain has no operating system. The brain has no programming. There's no Windows. There's no Pentium chip. There's no CPU. There are no subroutines. Nothing. There's nothing in a computer that even vaguely looks like a digital computer. So what is the brain? The brain is a learning machine. It is a neural network of sorts which rewires itself after learning every task. Therefore, it does use some digital, some analog in a combination, but as you correctly pointed out, reading what these neurons do is beyond our capability. So what we do in the laboratory is we cheat. We simply see a configuration of neurons corresponding to moving your arm like this. Then we create a dictionary that this means certain number of neurons. Therefore, when you think going like this, it'll excite those neurons. So we get a dictionary this way. Very clumsy, but that's what we do in the laboratory because we cannot read a neural network's messages and convert it into digital. That was the problem. Now we have computers that can do that, create this dictionary. That's how we get these gorgeous pictures of thought. That's how we can move robot arms. But it's all done by cheating because we really don't know how this neural networks, how it operates.